Okay, guys, we're getting started. As a reminder, in case you weren't aware, Monday's a holiday, so don't show up to class. I won't have office hours, right? I will still try to answer questions on Piazza, or not Piazza, Campus Wi-Fi if I have time, but be aware of that. Your final homework assignment is out now, I guess, so get started on it. It's in C. Your exception homework is really easy. It should only take you like an hour or something like that to do, maybe 2. So you don't have to budget much time for that, but the C one is going to be a bit more difficult because all the stuff that you've been used to working with is now gone, and you have to deal with pointers a lot more, and you have to deal with dynamic memory management a lot more. And dealing with that tends to be a bit of a difficulty for everybody the first time they have to work with it. So start early on that one. Make sure you have questions, ask, and then your final project will be out on no later than Tuesday for you to start on. Yeah.
Can you write tests and check if you have allocated?
It's not really possible to write like tests in Google tests that check that. You'd have to run another program called Valgrind on top of your code to verify if there are any memory leaks. And that one can only test to see if there are memory leaks in the sections of code that are exercised. So like if you call function 1 and function 1 has memory leaks when you're on Valgrind, then it'll tell you there's a memory leak that came from there. But if function 2 also has a memory leak, but your code that you're running for whatever reason right now doesn't call function 2, it won't tell you about that one because that code wasn't ran for you to create the memory to leak the memory. Does that make sense? Any other questions? Yeah. It's a homework assignment. Yes. It'll either be like Tic-Tac, it'll either be Battleship or a game like Backgammon, if you've ever played that before. Okay, so we're going to pick up from where we left off. Last time we were talking about dynamically allocating memory in C. Also, there's a set of slides up, which I don't think we'll have time to cover today, but will be really useful for doing your current homework assignment about reading from files. It is up there under the C++ to C stuff, so take a look through it. It's not that complicated. So if we do have time, we'll bounce back to it, but if not, it's up to you to read. So again, if you're dynamically allocating a multidimensional array, 1 star per dimension, right? And then you have to make sure that you actually go through and you dynamically allocate the space for each of the interior elements, right? So even though we're calling this like a 3-dimensional array, it's really a list of lists of lists. The first list is a list of double pointers. The second list is a list of single pointers. And each of those single pointers then points to an array of the actual values. So here's static arrays versus dynamic arrays. Static arrays, you have to know the size at compile time. But dynamic arrays, you only need to know the size at runtime. Static arrays, you can't change their size. Dynamic arrays, you can resize them. Static arrays are going to be constructed on the stack. Dynamic arrays, once you're dynamically allocating the space, will be on the heap. But since these static arrays are on the stack, you can't like return them from functions. That doesn't work. So they're kind of limited to the scope of the function that they're in. You could, of course, pass them to other functions for them to work on, and then modify their elements inside. That's fine, but you can't return static arrays. It's not going to work. And then again, when you call a function that needs a static array, it's going to need to accept a, you're going to have to specify the size of all the dimensions, but the first, which could lead you to rewriting multiple functions, and that can be a bit annoying. Dynamic arrays, again, doesn't matter how big each dimension is. As long as they're the same number of dimensions, the type won't change, and you'll be fine. So you should probably prefer which of these two types of arrays to work with. Dynamic, right? They're a lot more flexible and a lot easier to work with than the static arrays, so you should prefer to use them. So strings, there is no string class or string object in C++ and C, but there are C strings, and all C strings are arrays of characters that end with the null character, and the null character is written as /0. So they're just arrays, but they have that little special marker to mark the end of them. But it's really important that when you are working with C strings, that you make sure to put that null character there, because every single function that works with them is looking for that null character to know when to stop. And so if you forget to put that null character in there, it's not a C string anymore. It's just an array of characters. And the function is going to keep running until it happens to find a null character. That's going to cause some really weird behavior in your programs and potentially some sig faults. All these things are contained in string.h. So here's some of the methods. There's strlen, which will return the number of characters in the string. There's strcopy, which copies source to destination. Destination needs to be big enough to fit all of source. If it's not big enough, it's undefined what's going to happen, and you're probably going to get some really weird behavior, either segmentation faults or I don't know what. Str_n_copy will copy the first n characters from source to destination, so it's a bit safer so that you know that you couldn't copy more characters that you actually have space for in dest, and should probably be the one that you prefer to use over using just strcopy. But notice that one thing with str_n_copy is if you copy n characters and you don't reach the end of the string, then you will not put the null character in there. So you will not create a new C string. And so you'd have to make sure to go manually add in that null character there in that case. If n is larger than source, we'll just copy all of source over. Strcomp is used to compare two strings. It returns a negative number if str1 comes before str2, a positive number if str1 comes after str2, and 0 if the strings are the same. And then strcat will add the source onto the end of destination. And again, destination now needs to be big enough to fit both the destination and the source because you've added all those characters over there. But in all of these functions like strcopy and strcat, don't forget that you still need space for that null character as well, right? So if we had this string up here, if I do the strlen of cat, what am I going to get? Not a trick question. 3, right? Because there's 3 characters there. Now, next question, which is a little bit more complicated, how much space is actually occupied by the string? 4 characters, right? CAT null character. So 4 characters are actually taken up in space because this null character marks the end. So you need to be really careful about that you do always make sure to allocate space for these null characters, that there's space there. Otherwise, you're going to get weird behavior. Is this a C string? No, why not? There's no null character, right? C strings are just arrays of characters that end with that null character. And there's also str_n_cat, which will add at most n characters from source to destination, but it will always add at least, it will always put the null character in there, unlike strcopy. So you would either copy like all of source plus that one extra character for that null character to mark the end. So be careful with that. So what I want us to do right now is I want us to try writing some of these functions so you get a little bit of experience working with them. And we're going to be doing C executables now, and we'll do C11. Make sure to select C here. So again, you're still going to get the .h and .c files, but here we might have int my strlen const char star stir. So we'll start off with the easiest one first. You can do it. Okay. Did we not add this to? Okay, so how can we find the length of the string? Again, we're not going to be using the strlen, we're writing strlen. Loop until we find the null character, right? So we might have something like, int len, and then we might have something like this, for len equals 0. We want to keep going until, or we want to keep going for how long? Well, yeah, we want to keep going to the end of the array, and how will we know if we've reached the end? We'll hit the null character. So while stir at len doesn't equal the null character, right? Plus len. Oh, hey, great, we're done. This for loop doesn't have a body, right? Because we could just return len, because that's the answer. It's going to be the length of the string. Right? We do like C1, A2, T3, null character stop. So you get 3. What we want. And if having this semicolon here bothers you, you can just empty body. Thing happens. Any questions here? Okay. My stir copy, and this is a char star test const char star source. You can't put since there are no classes anymore, you can't put the const at the end. Work. So how can we copy source to dest? Yeah, one char at a time, right? So what's that going to look like? No, remember, it's assumed that the space for fitting the array is already there at destination, or for fitting all the characters. Right, so we could do a for loop for the length of the strlen of source, right? And to compute the strlen of source, what did it have to do? I had to go through all the characters, right? If I already had to go through all the characters to figure out how many there were, wouldn't it have been a little bit more efficient to just copy the characters as I went through them? Yeah, right? So again, we probably, all of the string functions are based off that null character. So all of them are going to run until we hit the null character. So you might have for int I is equal to 0, right? And we want to keep going while, again, source at I doesn't equal the null character, right? Plus I. And then we can just do dest at I is equal to source at I. And then these functions just return dest, so we return dest. Does that make sense? We'll do the same thing. So it doesn't really matter if I do I++ or plus I if that plus is by itself. They have the exact same effect. So what about char star my stir n copy? Stir n copy. So again, we want to copy the first n characters from source to destination. But if we reach the end of source, we want to stop early. But if we get the length of the string, what do we have to do? We have to go through all the characters, right? So again, we probably don't want to go through all the characters twice because that's twice the amount of work. It's going to take longer. We can be a little bit more efficient than that. Yeah. Yeah, there's an if break, right? So you can have something like, for int I equals 0, I less than n, plus I, right? Then we can do something like dest at I is equal to source at I. And then if source at I is equal to the null character, break. Then again, we return dest. Right, this guarantees that we copy over the null character if it's there. I should also have mentioned that we do have a mistake in our stir copy. See what it is? Yeah. We still have to copy the null character over, right? So I'm going to have int I up here. And then what you can just do is just do source at, or dest at I is equal to the null character. Because we'll be at the null character, right? Source at I is the null character. So that position I have to be at the null character. So just make dest at I equal to null character. So null terminate. And then over here, like, because stir and copy, right? If we reach the end of the string, we'll copy over the null character, right? But if we reach n first, will we put the null character? No, and that's exactly how stir and copy behaves. So we're being faithful to that, what that function says that it does. Are there any questions here? Okay. So now we might have something like char star or int stir comp. Stir 1 comes char pointer stir 2. So again, if strings are the same, we want to return 0. If string 1 comes before string 2, return a negative number. If string 1 comes after string 2, a positive number. So how are we going to make this happen? Again, we need to go through all the elements, right? So we should kind of write the for loops like we've been doing that keep comparing against the null character, right? So we might have something like, for, probably need this guy out here for a second. Or maybe this makes a little bit more sense. I don't know, so for. So true is not actually a type. There's no bools in C++ or in C. So if you want to use bools, you have to include a std bool. That's where they're defined at. That's where true is also defined. True ++ I. So we might say something like if stir 1 at I is less than stir 2 at I, what should we do? So returns a negative number if stir 1 comes before stir 2, a positive number if stir 1 comes after stir 2, and 0 if the strings are the same. Again, they compare it alphabetically by ASCII value, each character at a time. We return like -1, right? Else if stir 1 at I is greater than stir 2 at I, could return 1. But again, remember, in general, it's positive or negative numbers. I don't have to return -1 or +1. I could return 10 and it's still legal, or 25, still a positive number. Else if stir 1 at I is equal to the null character, and stir 2 at I is equal to the null character, what should we do? Return 0. And if they happen to be the same, go to the next iteration, right? Which is kind of what's being said to do here. Does this make sense? Another way that we could have written this, which is slightly less code, is we could have taken this statement up here and said, if they're the same, return 0. And then else if stir 1 at I doesn't equal stir 2 at I, return stir 1 at I minus stir 2 at I. Right? Because if stir 1 comes before stir 2, it'll be a small number minus a big number, which yields a negative number, right? If stir1 at I comes after stir2 at I, you'll have a big number minus a large number, which is positive. Yeah. So in that case, we would end up entering this else if. The values would be different, and the null character has like ASCII value 0. That's like numeric value 0, so it's like the earliest one. So if you have like null character minus a, you get a negative number. Even here, we'd still get the same effect. So this is like an alternative approach. Okay, and then finally we can do the last two, a char star stir cat, char star dest, char star source. So again, this one is supposed to add source onto the end of dest. So what should I do? First, we need to figure out how long dest is, right, to figure out its end, right? So we might have something like int dest len is equal to my stir len of dest. My stir len, yeah. My stir len. So we know how long destination is. And then now that we know how long the destination is, what should we start doing with source? To start copying the characters, right? To the end, at that position, to the end of dest, right? So it would be cool if we could use what function? Because we want to copy one string from one location to another. Stir copy, right? But here's the cool trick. We can use that. So we can do my stir copy, right? But do we want to copy? So we want to copy source, right? All of that. Now, where do we want to start from, though, in dest? Do we want to start at the beginning of dest? At dest plus len. Not dest plus, yes, dest len. Do you guys have any questions about this part? Because that's a bit different. Pointer arithmetic, right? So if what we were doing for our first string, if our first string over here was cat, this is destination. And let's say this array is at location 100 of memory. So dest has value 100 in it. So what's the location of this first character? What's the address of this first character? 100. The second character? 101, 102, 103. And now let's assume that the other string that we wanted to copy, right, our source, was dog. Right? So over here, again, this is some array of characters. This might be at location 200. So we have 200, 201, 202, 203. And so what's the length of destination? We call stir len on it. 3. So what's dest plus 3? 103, right? And so where would we want to start copying the characters to? Right here, right? But we assume that there's like enough space to fit the rest of the stuff. Right? So 104, 105, 106, 107. Right? So I want to start copying at location 103 in memory. And I'm going to start copying from location 200. So we put D, O, G, full character. And we're done. Does that make sense? Yes. Oh, then weird stuff happens. Again, it's undefined what happens when you go out of bounds on an array access. So you might get a segmentation fault, you might overwrite some other variables, or you might not see any error occur at all on your particular machine. But if you go and you compile it on a different machine, you might now get different errors and different weird behavior. It's undefined what's supposed to happen if you go out of bounds on an array access. Okay. So yes. Yes. Yep.
But len would be.
Oh. Destlen is an integer. Why is this not my? Sorry. Wait. Oh. This one shouldn't be const. And yes, I do need to return destination. And then this one should have been const here. Okay, so back to your question.
Yeah, so it takes. So passing it.
So a integer pointer, or I should say a pointer plus a integer yields a pointer. But again, what's stored in a pointer? An address. And what's an address? It's just simply a number, right? So, but the types, they matter. Like you can't dereference an integer, but you can dereference a pointer. Yeah. Yes, so des plus deslen yields a pointer. So pointer plus integer yields pointer. Any other questions? Okay. And then we have char star my stir ncat, char star dest const char star source. And then int n. And the reason we're doing these is just so that you can get a little bit of use to like seeing the pointers being worked with, right? And understand like these functions are not magical. A person wrote them. They're not special. They're really simple. You can write them too. Okay, so I'm going to copy the first n characters. Yeah. Because we want to copy the contents of source to the end of dest. So I need to know how long destination is to know where its end is at to start copying there. Right? Right? If destination is 10 characters long, but the source is only 2 characters long, I want to start 10 elements past the beginning of destination, not 2 elements into it. So how can we copy the first n characters to the end of dest? And we might start with this. And then we could do n copy, right? Dest plus destlen source n. Now, remember, we have to do like one other thing, which is we always have to make sure that this thing ends up being null terminated, right? Yeah, right? Because if it didn't put it in, then we're going to need to add in the null character. So what we can do, it's fairly simple, is we can just do dest at destlen plus n is equal to the null character. And it might be n plus 1. I wanted to add the first character of cat. So that would be destlen. We get the c copies 1. So yeah, plus 1. Great. It's now always going to be null terminated. And so you might be like, well, what happens if we don't copy over the entirety, right? All n characters. Is it still going to be valid? Yes, it will be. Here's a great way to figure this out. So let's say I do this. And include my string functions.h. And let's say I have this string char my stir bracket, say 10 is equal to So this made space for 10 characters, and it assigned the first 3 to be equal to CAT null character, right? And maybe we might even do this, cat dog. So that's going to take up, how many characters is this string going to take up? 7, right? The 3, or the 6 that are actually there, plus the 1 for the 7. And so if we look at this string, what it's going to look like is CATDOG, right? Null character. Now, what happens if I do this? Meister. Okay, so Meister at 3 is equal to the null character. And then I ask for what's this Meisterlen of Meister. What am I going to get here? 3, right? Because after we do this operation, right, we're going to have this CAT null character OG null character, right? That's what it's going to look like. And so when we do this, what's strlen going to do? Going to search for the first null character. And where does it find it? Here, at the 4th one, so our length would be 3. Does that make sense? Right, so with the n, with the stir cat, right? So again, let's say I had this guy right here. Again, now he's cat. And then I do something like my stir n cat. And we say I want to copy to my stir. The source might be dogman. And we might say 3. Right? So originally, our string right here looks like this, right? CAT null character. Agreed? So now let's say we do this, right? So we're going to copy the first 3 characters to the end. Because if we look back at our function, we said, hey, we find the length of my string. So what's the length of cat? 3, right? So I'm going to start at position 3, which is 0, 1, 2, 3. I'm going to start with the null character, right? And then I'm going to copy 3 characters, right? Because we called my stren copy, which is only going to copy 3. So after we do that, right, we're going to get CATDOG, right? Which is not, right, a string. But now we do this section right here, deslen plus n plus 1, and we want to see if this now works. So deslen is 3, 0, 1, 2, 3. We said that we wanted to copy 3, so that's 0, 1, 2, 3, then 1, 2, 3, because it should have been just plus 3. Not plus 1. Is equal to a 0, because deslen plus 3, 3 plus 3 is 6. So 0, 1, 2, 3, 4, 5, 6 is now the null character. And it's thrown in there. And again, if we copy the entire string, right? Now let's say I wanted to copy the first 20 instead. We might need to bump this up slightly. Right, so now we copy all the way to the end of the string, right? DOG man, which CATDOG MAN, and then we would have copied the null character over and then stopped. But then notice we assumed that we wanted to copy the first 20 characters, so this would probably need to be a little bit longer, 21, to be able to make this operation technically always legal. And then so at position 21, we would also throw in a null character. So somewhere down the line, there would also now be a null character. And in between, there'd be a lot of question marks. So at least the way that we've written this function, right, we're going to assume that we can always copy, n characters, right, to the destination. And so, you better make sure that whatever number you put in here, there's at least big enough for it to fit. This may or may not be how the actual stir and cat is implemented, but you'd assume that you could fit at least that many characters. So ours might have some undefined behavior if we change it back to be something like this, 15, that's big enough to fit cat dog man null character, right? That's only like 10 characters. But again, we would have gone to index like 20 and gone out of bounds back here. So something to watch out for. Any other questions? Yeah. That's undefined behavior. So you might get a segmentation fault. You might overwrite something else you care about, and you might not see any errors at all. So again, undefined behavior, I can't tell you what's going to happen on it. But no, nothing's going to report an error about it being wrong. Yes? Stir and copy does not add null characters, but stir and cat does add the null character. Okay. And so time marches on. So there's no for each loop, but there's still that index for loop that you can use, which we've been using this entire time. There's no namespaces or function overloading. All functions across all files and all libraries must have unique names, right? So you can't have duplicate names at all anymore. So watch out for that one. And there are no exceptions anymore, so you can't throw anything if something goes bad. So if there's something wrong happens in your function, you have to signify it a different way. Normally this was probably done by returning a value to signify success, and then your return value is actually is set through an output parameter. For example, this example on my right, it returns -1 if the index is out of bounds, and if it's in bounds, it will set the value and then return 0 to signify that it successfully set it. So notice this right here is like my error checking code that you should look to see if it worked or not. And then where I'm actually setting the value is down here in this return parameter. So if index is less than 0 or index is greater than or equal to len, I'm going to return -1, and I'm not going to try to use the index at all. But otherwise, star val, right, is equal to the array at the index, and I return 0 to signify my success. So anytime you were using, this function, you'd want to check the return value to see if something succeeded or not. Does that make sense? If you got something back beside the 0, that means something went wrong, and you should go handle it. Any questions here? There are no classes, but there are structs. These are the precursors to classes, and so they're somewhat similar to them, but there are differences. Structs only contain data. They can't contain any methods. But you could, of course, write just standalone functions that accept these objects of your type to work with. There are no destructors and constructors, so instances have to be created and destroyed manually. There's no protection levels. Everything is public. And the declaration syntax is different. So there's no public, private, or protected. If you want to declare a struct, you do typedef struct. Then you list the name here, which I call like the interior name. This is the name that you would use to refer to the struct inside of itself. So if the struct was somewhat like recursive in definition, right, you would want to use interior name here inside of the member definition. But you have to say struct that name instead. And then outside of this typedef, you can refer to the struct just via this class name. Again, your class declarations should be placed in the header file and included wherever they're needed. And again, the interior name is so that you can refer to it inside of the class. So for example, here's a person, so typedef struct person struct, age, weight, name, class is called person, typedef struct node struct, we have an int value. This should be a little s. Struct node struct pointer next. And the reason for having to use this interior name is, remember, C goes through your file top down one time. So it hasn't seen this name yet when we reach this line of code. It's only seen this name right here, struct node struct. So I have a pointer to the next node down the line. Does this make sense? Okay. So when you want to instantiate an instance of your struct, you just say whatever the name of your struct is, and then the variable name that you want to give it. You can have arrays of structs. You can have pointers to structs. You can dynamically allocate structs. You can dynamically allocate arrays of structs. You can have pointers to structs, right? They're no different than any other type. But there are no constructors for structs, so every struct you create starts off uninitialized. Its values are I don't know what. They're not defaulted to anything. They're just And then you have to, so because of that, you have to make sure that you manually initialize all the members before you use it. I might recommend writing functions that are like constructors to build these objects and then calling them to make sure they get created the right way. And then again, there's also no destructors, so any space that you create, right, is going to have to be manually deleted before the struct goes out of scope. So over here we have a make person struct that takes in their age, their weight, and their name. Make a person P, again, to access their members. Again, it's dot, just like with classes. So we set their age, we set their weight. Then we make space for their name. Oops. Notice that I did strlen of the name +1, right, to make space for that mul character. Again, times the size of the character down here. And then I copied that name over into the space that I dynamically allocated. And then I'm able to return my person. So then I can go ahead and use my person to do whatever I need to. And then afterwards, we can destroy the person when we're done with them. We take in a pointer to a person. If that person had a name, we delete their name. And then we set their name to null. And that should have been E arrow. Does that make sense? So what I want us to do with our last 9 minutes is there's a lot of stuff that we're probably missing from C++, right? Something might be like a string class. So what we might want to do is implement our own string class that has all the stuff that we're, unfortunately missing right now. So we'll create a new project. It's going to be C, not library, executable. And folder, and we might have, string class. Over here, we're going to have a new C++ source file. Apparently has to keep loading first. A new C++ source file. C. Check. You might call this string. And then, so over here in our header file, we're going to have our definition. So type def struct string underscore struct. That's just my convention for naming. Do whatever you feel like there. And then down here, we'll just call it string. Or, maybe we would call it like std string. And so what makes up a string? Yeah.
What is that?
The name of the class. So every time we're going to want to create a string, we'll say std underscore string. If you put nothing here, you would have to leave off the type def. And then every time you wanted an instance of this class, you'd say struct string underscore struct. This just makes it a lot easier, so I don't have to keep saying struct string underscore struct. Every time I can just say std underscore string, or I can name it right here. Because this is actually like two things at once. There's a type def, and then there's the struct declaration. And so, like a type def is like the using statement. Using some type is equal to some other name. So struct string underscore struct and std string, yes, you could use interchangeably. But I like using std string. So what makes up our string class? An array of characters. So how would I declare that? Yeah, char star like contents. Anything else? Yeah, we might probably want a length, right? Here as well. Okay. So here we might have a function that returns an std string, right? Make string. And then here we might have a const char star pointer, contents. So we can take in a C string. We might have like an std string make empty string. Takes no arguments, right? Like our no argument constructor. We might have something that's like void delete string. It takes in a std string pointer stir. Anything else we might want to do? Sure. Int string size. Const std string pointer stir. The reason I'm doing like this pointer over here is so that I don't have to copy the entire object over. I just get the pointer. So it's going to save time as opposed to having to copy over the entire object. You might also want something like a std string, copy string, and then that takes in a const char star pointer. Oops, not a const. A const std string pointer orig, right? This is like our copy constructor. Anything else we might want to do? Yeah, so you might say, you might have something like, that should probably be up here. So the question would be like, would you want a copy of the character that's there, or would you want a pointer to the character that's there? I mean, there might be both, right? Because sometimes it's easier to work with just the character and not have to dereference it. Sometimes you might want the character that's there to be able to modify it, right? So you might have something like, char, get char, const std string pointer. So give me the character at int position. So give me the character at this position. Yeah. Nope. Nope. doesn't exist, right? There's no plus. Yeah. Are you talking about this one right here or this one right here? Like this pointer here? Or both? So it points to the beginning of that object, wherever it's at. So we might have something, like a char pointer, get char p, const std string reference string pointer stir int pause, and this one I don't think we can. This should be fine, I think. Anything else we might want to do? We might want to be able to remove a character at a position. We might want to be able to insert a character at a position. We might want to be able to push a character to the end. We might want get front, get back, right? Those ones are a little bit more interesting. So like char star insert char into my std string pointer stir char val at int pause. Then we might have void remove char std string pointer stir int pause. Maybe this makes it a little bit more consistent. Right, like this thing that we keep accepting for all of these guys right here, what kind of pointer does it behave like from C++? It's this, right? This guy right here, this stir is like this pointer. It's the pointer to the object I want to perform the operation on. Then we might also have something like void push back char std string pointer stir, and then we might have something like void, or you like char. Oh yeah, char val, and then pop back char std string pointer stir. Okay, so this is what we'll be picking up with on Wednesday. You will find doing this will be pretty useful for your homework assignments. Yes? Oh, I don't know.